Hey everyone, so today we're going to peek behind the curtain of the digital world and look at the two kinds of brains that power pretty much every piece of tech you own, the microprocessor and the microcontroller. Now I know they sound almost the same, but trust me, they are worlds apart in what they do and how they do it.
I mean, just stop and think about it for a second. Your computer, it can do a million different things, right? You can browse the web, edit video, run all this complex software. But your washing machine, it does one thing, but it does that one thing perfectly every single time. So what's the deal? Well, the reason for that difference really comes down to the type of brain that's inside each one. Let's get into it. All right, first up, let's talk about the one you've probably heard of, the powerhouse that gets all the glory, the microprocessor, or just UP for short. This guy is pretty much the main character in the story of modern computing.
So at its core, a microprocessor is the central processing unit, the CPU. Its whole job is to be a number-crunching beast. It grabs instructions, figures out what they mean, and then gets to work executing them, doing all the math and logic. It's just pure, raw processing power.
But here's the catch. This super powerful brain can't do anything on its own. A microprocessor is kind of like a world-class chef who needs a fully stocked kitchen to work. It absolutely needs separate chips for memory, for handling your keyboard and mouse, and for all sorts of other things just to get the job done.
Now let's flip the coin and talk about the unsung hero of the tech world, the microcontroller, or MUSI. This is the hidden brain that you probably interact with dozens of times a day without even having a clue it's there.
And boom! Right there is the key difference. While a microprocessor is a CPU, a microcontroller has a CPU. But it also has everything else it needs to function. Its own memory, its own ways to talk to the outside world, all baked into one single self-sufficient chip. It's not just a brain, it's a whole mini-computer.
And because it's a complete all-in-one system, it's designed for a very specific purpose. A microcontroller isn't there to surf the web or play games. No, it's there to do one particular job inside a bigger device, like, say, controlling the cycles of your dishwasher or reading the temperature from a sensor.
All right, so now that we've met our two contenders, let's put them side by side. Let's really get into the nitty-gritty of what sets them apart. This is where it all clicks.
So this right here is the biggest, most fundamental difference. A microprocessor is a generalist. It's built to be a jack of all trades, to handle a huge range of tasks. A microcontroller, though, is a specialist. It's designed and programmed to do one specific job and to do it efficiently and reliably over and over and again.
And this table just breaks it down even more clearly. Because the microcontroller is this highly integrated system on a chip, it ends up being cheaper, way smaller, and it just sips power. The microprocessor, needing all those external parts, naturally has a higher system cost, and it's much hungrier for power. But what you get in return is just blazing fast speed. We're talking clock speeds over a gigahertz, which is perfect for that heavy-duty computing.
You know, it really all boils down to a classic trade-off. The microprocessor's need for other parts is actually its greatest strength. It gives it incredible versatility. A designer can pair it with as much memory or as many ports as a project needs. The microcontroller, on the other hand, gives up that flexibility for the huge advantage of being compact, all-in-one, and totally self-sufficient.
Okay, so that's the theory, but where do we actually find these two different kinds of brains out there in the real world?
Microcontrollers are literally the invisible workhorses of our lives. They're in your washing machine managing the wash cycles, in your car's engine, in your TV remote, and even in critical medical devices. Seriously, any device that does a dedicated, repetitive task, it's almost guaranteed there's a microcontroller inside.
And microprocessors, well, they power the devices where you need that awesome versatility and raw power. So think of anything you'd actually call a computer, your desktop, your laptop. These machines have to run a super complex operating system and handle any random app you throw at them, which is the perfect job for a microprocessor.
Okay, so after seeing all of this, it's pretty easy to start wondering which one is actually better. But honestly, that's not really the right question to ask.
This is the question everybody asks, right? Is it the powerful, super fast microprocessor or the efficient, all-in-one microcontroller? Who wins?
The thing is, the answer is neither. It's not about one being better than the other. It's about what's the best fit. It all comes down to what the system you're building actually needs. You wouldn't use a sledgehammer to hang a picture frame, and you wouldn't use a tiny hammer to knock down a wall, you know?
So here's the big takeaway.
If you need a brain for complex, very do-anything computing, you're going to choose a microprocessor. But if you need a brain for a single, specific, embedded task, you're going to go with the cheap and efficient microcontroller. It is truly about picking the right tool for the job.
And that kind of leaves us with a final thought to chew on. As more and more of our world gets smart, from coffee mugs to our shoes, just think about all the simple objects around you right now that could be the next to get their very own specialized microcontroller brain. What do you think is next? Thanks for tuning in.